The proof of concept demonstrator of the MDC ARTICo integration runs on a ping board, which features an FPGA plus an ARM-based dual-core microprocessor. The setup requires an USB camera and a desktop or laptop computer to run the user application. The first step is to put the embedded Linux on the board and run the target application. This application waits until the user interface establishes a connection via TCP/IP. Then, the user interface is executed on an external computer and the connection is made. When the link is established, the embedded application starts computing and sending data back to the computer. The user interface shows the input image, the result after processing, and the elapsed time for both reconfiguration stages and the processing stage. It is possible to modify the size of the input images from the user interface. Increasing the size of these images leads to more processing to be performed and thus to longer processing times. However, the data parallel nature of the underlying execution model makes the dynamic scaling of application transparent for the end user. The number of hardware accelerators used for processing can be also changed from the user interface. Dynamic and partial reconfiguration is used to alter the FPGA substrate and load different copies of any computing kernel in the ARTICo architecture. The aforementioned data parallel execution model present in ARTICo enables transparent scalability in terms of performance when increasing the number of accelerators. However, extra time needs to be used to perform dynamic and partial reconfiguration and register-based accelerator configuration. Coarse-grained reconfiguration, which is provided by MDC, and dynamic and partial reconfiguration, which is provided by ARTICo, are supported in this setup. Switching from one kernel to another using dynamic and partial reconfiguration changes completely the circuit present in the FPGA fabric. However, it is a time-consuming process. In this example, reconfiguration times are around 100 milliseconds. Variations in these numbers are due to the non-real-time nature of the Linux kernel used. On the other hand, switching kernels using coarse-grained reconfiguration provides fast functional changes at the expense of increased logic resources inside the FPGA, since all functionalities must coexist. In this example, both image processing kernels are present within one accelerator and can be switched using configuration registers and multiplexers in around 100 microseconds. MDC power reconfiguration is negligible when compared to the time spent during additional accelerator configuration. Using the attached USB camera, the ping board can be used to process not only static images, but also live video. For this demo, the hardware accelerators have been modified to support functional fault injection, which means that the logic will either work or not. Using the inherent fault tolerance capability of the ARTICo architecture, it is possible to enable triple module redundancy and mask these faults. Then, The internal monitoring infrastructure can be used to report the number of faults for each reconfigurable slot.